All right, here's my PeckaKucha for atomic theory and atomic models. So over the course of this presentation, you will see how the atomic model has changed over time. So I'm starting with kind of a current model of the atom. So here's what most people think of when they think of an atom. Democritus, he was considered, the father of the atom because he was the very first person to come up with the concept of the atom. He realized that when you took things like rocks and broke them in half, they continued to split into smaller and smaller and smaller particles. So he came up with this concept of the atom. This is kind of his model of the atom. There's no protons, there's no neutrons, there's no electrons. He just kind of thought of it as a solid sphere, which is better than thinking of it as everything being made of earth, wind, water, fire, all of the things that they previously thought that everything was made out of. John Dalton took this one step further, and he came up with Dalton's atomic theory, which there are multiple parts to. But he came up with this concept that atoms were these indivisible particles, so even he did not realize that there were protons, neutrons, and electrons, but at least he started putting these things together in compounds. And this is an image of his model of the atom, which also you can see does not contain protons, neutrons, and electrons. But he started realizing that if you take these atoms of different elements and combine them together chemically, you can start making new things. So he came up with this concept of the actual atom and elements. This is J.J. Thomson. J.J. Thomson is the father of the electron. He used a cathode ray tube to discover that atoms actually had charged particles inside of them, specifically negative charged particles inside of them. And those negative charged particles were the electron. So here's an image of the cathode ray tube. And if it's got a positive end and a negative end, and you can actually get the electrons to travel along this cathode ray tube. And this is how tube televisions work. So this next slide is showing Thomson's model of the atom. It's called the plum pudding model because the positives, the things that were positively charged, are like the pudding, and then the raisins are like little electrons that would be in plum pudding. You can also see it as the watermelon model. We've got electrons here, and we've got the watermelon flesh as being the positive part. So this is Ernest Rutherford. Ernest Rutherford is a student of J.J. Thomson, and he came up with the Rutherford's model of the atom. He actually discovered the nucleus, and he discovered the positive proton. J.J. Thomson knew it was there, but he hadn't actually discovered it. Rutherford is the one that gets the credit for that. And this is the model of his gold foil experiment. So he shot alpha particles at a piece of gold foil. And alpha particles have a positive charge. Most of the alpha particles went straight through, but some of them bounced at angles and some of them came back. So they were repelled by the positive nucleus. And so this is his model of the atom, with protons and neutrons in the middle. And he really didn't know that neutrons existed. He just knew that there had to be something else in that nucleus to make up for the mass. So he has the protons in the center and the electrons going around the outside. But that was about the extent of what he knew. But at least we're starting to see more of the current model. So this is Niels Bohr. Niels Bohr was a student of Rutherford, and he is credited with coming up with the Bohr model of the atom that we still use today in terms of describing where the electrons are located. So he took discovery of the nucleus one step further, and you can see in this Bohr model, here are his electrons. So everything is going to have 2 electrons in the first shell, 8 valence electrons in the second shell, 8 valence in the third shell, and so on and so forth. And he actually accounted for all of the electrons in an atom. This isn't correct because he shows them in what's called a planetary model. This is James Chadwick. He is credited in 1932 with the discovery of the neutron, so actually proving that the neutron does exist in the nucleus, accounting for half of the mass of the atom, or at least a majority of the mass of the atom. Protons and neutrons together in the nucleus make up the mass. So you've got now protons and neutrons in the nucleus and electrons in these orbitals. And this was the model that was generally considered correct until we've discovered the current model, which is close to this, but the electrons are not in these nice, neat, perfect orbits. This is Edwin Schrödinger. He is most famous for Schrödinger's cat. If you can't see the cat, does it really exist? So if you can't see the electron, does it really exist? He realized that electrons are not in these nice, neat orbitals. Electrons are in more of these fuzzy boundary type areas, which we now call the electron cloud model. So instead of the electrons being in these perfect orbits around the nucleus, they exist in these kind of shell or fuzzy regions. So s orbitals are circular, p orbitals are dumbbell shaped, d orbitals are four-leaf clover shaped. And each one gets further and further and further out from the nucleus. So this is the S. These are what the P's look like. There's 3 of them. These are what the D's look like, and these are what the F's look like. And for a big atom, all of these would be on top of each other, which is why it creates the electron cloud model, because you can't really tell where the electrons are or what specific orbital they're in. You just know that they're in this region somewhere. So here's our model changing over time. Here was Dalton's, to Thomson's plum pudding model, to Rutherford's with a nucleus, to Bohr's with the orbits, and then to Schrödinger, the electron cloud model, showing the electrons going through orbits, but not in these perfect circular orbits, more like the SPDNF. And here's another model of it too, showing Dalton to Thomson's plum pudding, to the Rutherford having the nucleus, to Bohr having the different energy levels, and now to Schrödinger's model where you've got the electron cloud, which are these regions where you can find a whole bunch of electrons.